If not, we can move to the general discussion and open up the floor, both online and here in the room. And if there's any questions for any of the speakers, please feel free to go to the microphone and ask those questions. Or for those online, just type your question in the chat window.
Thanks. This is Brian Day from NASA Survey. The gamma pit certainly looks irresistible, but from your description of your ballistic penetrators, it seems like they might be ideal probes to use with irregular Mare patches and perhaps be able to constrain whether their seemingly anomalous CSFDs are in fact a function of age or perhaps instead geotechnical properties. Am I interpreting this correctly? And if so, is this something you're looking at perhaps doing?
You're talking about the irregular Mare patches like the INA and those things?
Exactly, yes.
We weren't aware of any clips.
Right. They haven't been targeted yet.
Any prism calls on that test. It took 6 months of work to dig into. Can you hear me?
Yeah,
Yes.
we can hear you.
Yeah, it took about 6 months of work to dig into the gamma pit. I mean, that wasn't easy, right? It's not. These things will just fall off the table. And so, yeah, that would be very interesting. INA is a very interesting place that I think would be a very good one for penetrators because it's so, how would you move around in it? Otherwise. I mean, if you want to talk about that, send me an email and we can talk about that.
I'll do so. Thank you.
Okay, any other questions?
Hey, I wanted to go back to L-Cirrus with Maxar Space Robotics working on the sampler program, and mainly curious about if you're concerned about other payloads disturbing the lunar environment that you're trying to sample, or if that is somewhat advantageous. I know other payloads want lunar regolith delivered to a certain spot for them, so I'm just curious about the L-Cirrus impacts on that.
Yeah, I mean, certainly for us, any disturbances to the surface. So if we can measure the landing site or the area around the landing site before and then after, that certainly provides really interesting science that we can do both compositionally, but also thermophysically. And so I know that Paul Hain, the PI, has been coordinating with some of the other instruments to try to develop a mission operations plan to be able to coordinate things like that, because we're definitely interested in doing that.
Cool. Thank you.
Yep.
We have a question from Marshall in the chat. Marshall, do you want to ask your question?
Can you hear me?
Yes.
This question is for Alex Donner. What is the maximum velocity that you can resolve? It seemed like you had a limit there of 100 kilometers a second or so. Was that just you don't think you're going to get anything faster, or is that like an instrumental limit? I'm interested to hear an interstellar meteoroids and trying to limit them.
As far as PPDF itself is concerned, I don't know of a strict velocity limit on the detector. The 70 kilometer per second limit that was posted was the max we expect to see on the moon. I'm not sure how fast the interstellar grains are going. I don't know if they're much faster than that. I'm pretty sure they're around 20 actually. So I'm pretty sure we should be able to detect those if they're sufficiently massive.
Thank you.
I have a question for Paul Blase. If Paul, you're still listening.
Sorry, couldn't find the right button to unmute myself.
No, that's fine. Yeah. So this is Dave Blewett. I have a question about your sailcraft. How well, what's the knowledge and control over the craft's orientation? It would seem that's important for, being able to point a camera or understand the three-dimensional magnetic field as you're flying by. So how well, would you be able to know the sailcraft's orientation?
Well, I mean, how accurately would we be able to measure it, or how would we set it?
Yeah, I guess there's two things. One is knowledge and one is control.
Okay, I mean, knowledge would have an onboard, MEMS obviously, but inertial nav unit. And you could also use the cameras to detect Apophis itself, the star, do stellar angular measurements there. Being able to set it, basically it would always be away from the beam during the actual drive launch process. But after that, there's a number of ways that we could control it. Use magnetorquers in this case against the Earth's field. There are also some work being done on MEMS micro thrusters for nanosatellites. That would be of a side where we could get a few dozen attitude control shifts. But I think the prime mechanism here would be with the magnetorquer. For longer missions, if you're going out to asteroids or trying to catch up with a Mau, you'd probably use actual sail tacking, because the sail itself would work against the sun just as well as against the lasers. So you could use various ways to tack using either laser or solar pressure.
Great, thanks for that, Paul. So I think with that question, we're going to end the session. So let's thank all the speakers again one more time.